to this webinar this morning from the France Water team, together with Water Alliance, the Dutch-French webinar on water technology. My name is Harold Brons. I'm Business Development Manager at Water Alliance. I will be moderating together with France Water team today. Before we start with to go through the program of today, I would like to ask you for a few house rules. We would encourage all the people who listen in to put their questions in the chat. We will have one session after the Managing Director of France Water team, Mr. Francis Bertrand, that you can ask some questions after his presentations. For the rest, we will do them at the end of the session today during a Q&A. There is also a Q&A format within Zoom that you can also use, and we will coordinate that towards the end. We would like to ask the speakers today, when they're not presenting, to put their camera off and to mute the microphone. And just before they're up, please switch them on, and I will give you the control to go through your presentation. The program for today is, after my short welcome, is that we'll give the word to France Water team to talk about themselves and to introduce themselves to the Dutch audience and tell something about what's happening in France. I will do the same for the Netherlands, after which we go through 3 pitches from French companies and from Dutch companies, after which we will go into the Q&A and then the closing. So I propose that we start, and I would like to give the word to Mr. Francis Bertrand, Managing Director of France Water team. I will give you the control, and looking forward to hear your presentation, Francis.
Thank you. Good morning, all. Do you listen me clearly? Seems to be. Okay. So a few words about France Water team, and to make it brief and controlling the slideshow. Okay. France Water team is namely what we call in France competitiveness clusters, meaning we have a specific label given by the government to fulfill 3 main missions that you can see on these slides. But I should say and express them in a slightly different way. Our job is to connecting academics and SMEs mainly, and our audience is a bit broader than that, absolutely clearly, because jointly to the SMEs there are some huge group in the water domain. You know them. In France, we've got some kind of key players, should say. We have to tackle with the innovation question, and our duty is to join and to merge, I should say to group our members and make them being more innovative. Our job is specifically to drive them to the best project possible and to the best funding desk for their project. Third activity is to link these actors and to help them going international. So 3 main mission, a bit different than the one you've got here, but anyway, when we look at the practical things, this is what I just said, which is driving us. A few words about our organization. I won't go too far into the details. I don't want to lose you on that. But France Water team, keep in mind this word, is a federation of clusters. Legally speaking, we are an association, and we've got some founding members that I'm sure you know about, because from the French part of this audience, you are members of one of these clusters, namely I'm speaking about Aqua Valley, Dream and Hydrolysis, which have been for years and now for 10 years competitiveness clusters. So it means that now, and I'm looking after the next slide just to give you numbers. No, I'm back. Now, when you speak to France Water team, you are speaking to these clusters, and specifically you are speaking to a bunch of 500 of members. I just told about this, but once again, mainly SMEs in numbers, big groups, not exclusively on the water domain, because you know that we by ourselves, we will go far, but not too far. And we have to be connected to additional skills or to additional domains like the IT one, like the farming one and the agriculture one. And we've got key players in as members in these fields as well. We are going light and fast, meaning that talking about governing just a board to drive our activities, and no direct membership for the companies. What we want to achieve with this indirect membership is to keep at the regional level the activities of the members, of our affiliated members, I should say. Last word on that slide about our organization. We are shaped to extend or to expand our activity, meaning we want to connect to additional clusters, just to merge and just to group a bit more the water ecosystem and the connected activities in France. So currently, we are starting discussing with additional clusters, what we will call them associated members. And this discussion will probably, the target is to be connected to something like 8 or 9 more clusters on the French territory for sure. Our teams, well, one, I just explained how we are working, what are the main duties. Here you've got the keywords. We are working international level to boost our members in such this direction. We have been setting up a project factory, meaning we are let's say available and able to help any kind of companies, especially the SMEs, to be honest, to define and submit a successful project to the funding desk at all levels, regional, national, European as well. Speaking about Europe, we've got two additional activities which are to involve our clusters and France Water team as well in consortia founded by European money, and to be active in Brussels, to be, let's say, visible in Brussels, to, let's say, give our words or give the words of our members to the decision makers there. I don't go too far on that, but I think you know how and this kind of action has to be undertaken. Networking, meaning that we do technical days, we do workshop, we do exhibition in France, and when we speak about international, we help our members to go and to attend some exhibition all around the world. The keyword growth refers to the fact that for a long time we've been helping companies to fund their innovation project, and now we are starting the work or the activity or help the company to fund their overall activity. And by the way, nothing is visible, nothing is hearable without a good communication team. And this is the last, but not the least of our action, because speaking of us, we are speaking about our members as well. I don't want to lose you on that magic and colorful table, but this is how we see the world, to be honest. Stakes and issues, quantity, quality, environment, digital transition. So far, the details, the way we are looking at them, we are considering them, and let's say the markets and the sectors, the economic sectors we are addressing. The more red on the dark red is the cell, the more we've got activities and we're considering this market important for our members and important for us. So this is the picture of the reality. This is the picture we refer to, or the analysis we refer to when we choose to go on one domain or another. What else? Yes, a few words about the challenges in France, but I think that more or less you will find in global terms the same in the Netherlands. But anyway, from the French way of looking at that, what we see is something to deal with the quality of drinking and drinking of water and natural water as well. Specifically, we look at how to restore both environment and biodiversity. What we look after is to considering sludge management in additional or alternative ways. What else? For sure, the impact of the digital transition is described here, and namely at the beginning of the chain, at the moment we have to produce data. And in addition to that, because this is something usual, so to say, new pollutants every day, should say, means that we have to detect and to treat them in the best way. Next, about the quantity, because I think you're all aware of the last 3 or 4 summers we've been living. And then the question of quantity, I should say the question of conflict to the access, to accessing the water is taking, let's say, huge position in our mind. And it means that we have to save the water. We have to generate new resources, and I'm speaking about reuse, for example. And we have to store the water. And one of the key questions, the key field of not yet in engineering, but research for the moment, is the groundwater storage. Last of our challenges, the one which are more transverse. When you look at the 2 previous key or group of challenges, quantity and quality, logically you are driven to think about how to in a smarter way manage that and manage the infrastructure. So there is a bunch of work to be undertaken on that. In addition to this, it means that we, and in the pipes you will find cold or hot water anyway, so there is something somewhere, a kind of energy to take and to manage. So this is an additional transverse topic for us. And more globally, and I've been speaking about for a while now, the digitalization question is in our mind in a technical way. As you can see, new connectors, new sensors, sorry, all the group of the keywords about the, big data, artificial intelligence, and so far and so on. Yes, but I should say that prior to develop a big data system, you have to collect a bunch of data to manage them. Last, the blockchain as well. But I should say that on top of that, on parallel to that, speaking about the digitalization, we have to train and we have to help our SMEs to jump into this transition, because our ecosystem is populated of small and very small companies, meaning that the IT competencies and the IT skills is probably not at the best level everywhere. So we have to help them and to help the people to learn and to teach the people there to be, let's say, more fluent with this impact. I don't want to go too far on that because I have no watch and I don't know how many times and minutes I've been spending on that presentation, but as I have to leave, I'm okay to answer your question right now, and I give back the floor to Aro.
Thank you very much, Francis Bertrand. There's no questions to the Q&A. Maybe if somebody has a specific question for you, he can still do so. One point I would like to address maybe to you, maybe you could give your comment. Roughly, what do you see what do you see as a reaction or a consequence of the COVID pandemic for the water sector in France? Do you see that business as usual because water is a primary resource, or are there changes or additional investment maybe by water companies?
No, there is cascade, and there is a group of issues which the COVID has been rising up. The first is we need to, or we find out that we can manage and we can use the water to as a warning sign about the presence of the COVID. If you have a couple of minutes, look after the keywords projet Aubépine on the web, and you find out there's the Sorbonne University in Paris, jointly with Eau de Paris, have been working on the detection of the traces of COVID in the effluents. And it can be a warning sign. And if you step back and look at the global picture, you can imagine that detecting pollutants or detecting substances can be an additional or an extension of our work. So I think there is an issue on that. And in the end of the chain, there is the management of the sludges. And what I discovered, because I'm not an expert in the water sector, so to say, is that when you have to change these sludges into, and you have to manage them to, well, I want to go directly to the fact. In France, the water treatment plants, when they are depending on a big company or big municipalities, are okay to treat these sludges. But there is a lot of small, poor water plant treatment who cannot manage that, who cannot handle that questions. So we have to improve these small facilities. And what I think is clearly there is an open space or an open door for innovation because these plants are very small, are probably in less rich part of the territory. It means that they have to be and they have to find out some efficient and costless solutions. So there is an opportunity for innovation. There is an opportunity for the members of our clusters on that.
I guess because they cannot make use of economy of scale, the economic effect for them is additionally big. But maybe, yeah, so if some of the Dutch participants today want to join on that a little bit in their presentation, they're welcome to exchange on that last point as well. We see COVID detection too as part of an early warning system in the Netherlands. So I see we have one question for you in the Q&A, so let me have a look. Are the French SME able to introduce their innovations into the French market and solving the French challenges you mentioned? Okay, this is already a little bit a door also to cooperation, I see.
Excuse me, I was looking at the discussion, so I didn't get your point, Taro, sorry.
No. So one participant is asking, are the French SME able to introduce their innovation into the French market and solving the French challenges you mentioned? So do you see certain areas in the challenges you mentioned where you think international cooperation is especially wanted because there's maybe still an open area?
It's a very open question, Aro, and probably I would give just an open answer. I don't want to be elusive, but there is just a couple of hours separating our two countries, meaning that connection between companies to improve their answer and to address some specific segment of the market should be welcome for sure. So So this is an elusive answer, but this is very positive in my mind. There is open spaces for connection and for sharing opportunities and push some additional innovation on the French territory for sure.
Okay. No, I agree. And of course, our SMEs, we see that also are usually working in quite a specific field, and they are innovative in their specific field of operation, which can be very broad, as you mentioned, of course. From OP to monitoring to wastewater treatment or drinking water. It's a broad area and field where we work in. Okay.
But I can quickly add something on that and the way to connect, because I will speak with rough words and just to be clear and to make it short. 80% of the water activity is paid or is bought by public authorities, and I think this is absolutely the same in the Netherlands. These organizations have specific and legally binding way to buy. So my proposal on that is that for the foreign and the SMEs from Netherlands is to get connected to a French SME to answer the calls issued by the public authorities, because except for, I should say, companies of bigger size, it's not easy to answer this kind of call for tender. So joining and connecting with a French SME is, on my view, one of the best ways to open and to have activities on the French territory.
No, I completely agree. In my point of view, this is also the win-win, isn't it? Because you have, because the Dutch or the French going to the Netherlands or the Dutch going to France, they need something innovative because it needs added value. But then there is a technology supplier and somebody for the implementation and the local servicing, the local rules and regulations, and both can do a project together, ideally where 1 and 1 is 3, I would say, in the technical solution that they present to the customer. So no, I can completely agree that. Then I would like to thank you very much for your part in the presentation. I will take over. Looking forward to continue our cooperation. Merci.
I will be happy to. Okay. Thank you.
So I will take over and do a little bit the same for the Dutch side, talking about Water Campus, Water Alliance, and some of the Dutch issues that we see in quite generic scope. So Water Alliance is part of Water Campus, which is a water technology innovation ecosystem in the Netherlands. I will touch on it very briefly, but we have 3 main parts in this ecosystem. That is at 1 o'clock, the scientific part, where fundamental scientific research is done at WETSES. WETSES is not a university itself, but an institute where professors from universities guide PhD students in a 4-year research program. If then IP has been found, we come to the 4 o'clock applied research phase to scale up the fundamental water technology research for longer term trials at a larger scale, or even at a demo site full scale. And of course, to support them in the applied research phase to go and find that first launching customer. In the final part, third of the ecosystem, there is Water Alliance, where we support our members and the Dutch water technology sector in the cooperation, matchmaking, and also to go abroad and have international connections. So very briefly, we have the science part, the applied research part at CEW, the Center of Expertise Water Technology, and we have the business part at Water Alliance. Of course, the education is a big part at WETSES and CEW, because we also need, of course, the technologists, process engineers, installation guys, or service engineers to, of course, implement and maintain the water technology and the installations. A little bit about WETSES, but I'll keep it very short. So there's 23 European universities bringing in a professor to do that fundamental water technology research, but always on a theme introduced by a company. So the market relevance is given. And so there's 65 PhDs running on those teams for the 4-year program. I think one of the unique aspects of it that is that you see that if the biologist gets stuck, he can still also discuss or get ideas from, for example, the chemist. So the universities also join, and different faculties can join forces to solve issues that occur during the research phase, which is quite unique in my opinion. Then, as mentioned, CEW is there for application development, product development, and the guidance of testing. For example, in the Applied Research Lab, the Water Application Center. We as Water Alliance, we have about 110 Dutch members, mostly also SMEs and some of the startups from the ecosystem. But we do, of course, also support the broader water technology in the Netherlands with business development and branding and promotion. And some of the Dutch water topics. Also, we had just what we heard before from Monsieur Bertrand as well, face in the last years more and more drought in summer, forcing us to look at it. So I completely acknowledge that point, that we too need aquifer recharge and subsurface water storage is a hot topic. How to keep groundwater levels, the rain that is falling in the winter, how do we keep it for the dry summers? And in that talk, you see that municipal and industry is more and more looking at reuse applications. So also on the municipal side, this comes a little bit together with the micropollutant discussion or sensitivity that is there. Because if, for example, a municipal wastewater treatment plant is looking at microplastics or medicine removal, which there is an increasing sensitivity because of ecological, etc. Consequences, then you create a quality of water that can, of course, be very properly be used, possibly by an industry. On the other side, I think the municipal wastewater treatment plants very much look at themselves as an energy and nutrient factory nowadays. So not simply treating wastewater, no, it's becoming also an energy and nutrient factory. I will come back to that a little bit later. So these are the topics I will slowly go through. So wastewater treatment works are looking a lot at energy optimization. For example, by a company called PAC with Anamox side stream treatment. So had the direct way from ammonium to nitrogen gas without the whole nitrification, denitrification process, which costs a lot of energy. A hot topic is the thermal hydrolysis of sludge. I guess here also we see the need for economy of scale, but more biogas and less quantity. And maybe more relevant for the Netherlands than in France, but I can't really judge or don't know the French situation, but this aquathermal solution. So heat recovery from wastewater. We now see first concrete projects in the Netherlands where city blocks are being heated by a central heating system, but where the lower or the smaller delta T of wastewater is used to do that city heating. Another topic is the cellulose recovery from the municipal wastewater, also to reduce the sludge amount. We have one speaker today who will talk about that in more detail. And for example, if you talk about nutrients, you talk about struvite harvesting, magnesium ammonium phosphate. Phosphate being an endless resource. So if we can get that out of the wastewater, we of course can close a cycle, and we also have a value chain. With regard to production of bioplastics, we recently got the news that there's a full-scale project now being planned in the Netherlands at a municipal wastewater treatment site to produce biopolymers from sewage sludge. Well, this point was also briefly mentioned. I think is also a topic already quite some time in France. If we want to remove micropollutants, for example, with a quaternary treatment step, membranes, AOP, or absorption, also an option, we create such a good quality of water that this can be a fit for purpose water for the industry. And if that, for example, means like a project I'm thinking of, that the industry doesn't need to pump up saline groundwater, for which you would need a reverse osmosis installation, then you have additional added value. You create, you remove those trace substances and create value also for industry and, for example, less saline groundwater if you're close to the sea. It's of course all non-potable, so we do really talk about fit for purpose industry water or irrigation in the agriculture. In that aspect, we do also see more and more water technologies in the built environment in our cluster. Two examples here: decentralized treatment with source separated sanitation by DESA. So vacuum toilets, but you treat differently the black, the gray, and the rainwater, and get nutrients out, energy out, or reuse the water. And it is a very interesting solution. For example, also when it prevents you from having to invest in a very large sewage treatment network. There is really a business case for such solutions. And the other one to the right from Coluberis is a metabolic network reactor. These are also smaller footprint municipal wastewater treatment plants, but almost with a recreational character. So combining the treatment with a integration in a building as a green place to spend time. Another one is Hydrolysis. So in-house gray water recycling. To put it briefly, you use your shower water, treat it in a Hydrolysis, the size of a refrigerator, and use that water coming from the Hydrolysis to flush your toilet instead of high-value drinking water. Or you use it to top up the pool. So Hydrolysis is very much expanding at this moment to worldwide, actually, to solve that kind of inbuilt household solution. Well, I think this is a topic I did not really put a lot of effort in it, but it is a large market, of course, what also Mr. Bertrand touched base upon: the digital transformation, Industry 4.0, the Internet of Things, artificial intelligence, big data. And rightfully said also by France Water team, I think also very important in that talk is also the censoring, so the production of data, let me put it like that. And I think I see also at Let's a large effort in developing lower costs, effective, generic type of sensors is a hot topic. AquaSuite is one of our members, quite active in this field, with an analyst and autopilot for utilities. One interesting point I wanted to mention today is the target that the horticulture sector and the government have issued on to become emission-free by 2027. And this means a far-reaching removal of crop protection products for water that you discharge, although you try to limit discharge as much as possible, so reuse almost all the water by growth optimization and zero-emission growing. These are typical AOP type of solutions. So here from Remmen, an example with the UV for disinfection and the hydrogen peroxide for the oxidation step. Removing of the crop protection products, pathogens, and the microorganisms to a high degree to protect in the end the ecology and the environment. Another aspect I briefly wanted to touch on, where we see initiatives in municipal wastewater treatment as well. In general, biological processes are interesting. However, they cost generally quite a lot of energy for aeration, for the mineralization process. So the idea has been developed to do complete 100% physical chemical treatment line. In this case, with electrocoagulation, dissolved air flotation, nanofiltration. But and some of these technologies also in the physical chemical treatment are, for example, also used by Bluecon. very interesting decentralized municipal wastewater treatment plants up to with 20,000 people equivalents, but also smaller, of course. And I think also a charming solution when for example, coastal regions with a lot of tourists in summer, these kind of systems you can really easily switch off in winter or put an extra line in operation when you have more or stronger population because of tourists, for example. Well, this was in brief my presentation. Francis Bertrand, may I give you briefly the floor to introduce the French companies that will be presented?
I'd like to, but to be honest, I'm jumping in the next meeting right now, which is occurring a bit of the incidents. But if you can give me the list, I will refresh my mind to have the specific and the best words.
Well, they will of course pitch themselves. It's Nereus, Altereo, and Watchfrog that will be presenting today.
I didn't get you.
I see the first slide of Nereus. Emmanuel Trouvé, good morning.
Shall we just start, Francis? Is that okay?
Yes, it would be better.
Okay.
It would be better. Thank you.
Manuel, I will give you the control.
Okay.
Yeah. There you are. You should be able to go through your presentation now.
Hope so. So in this first slide, I will present the heart of Nereus technology. Nereus, sorry. Nereus is now a 7-year company founded in 2013, and we are producing systems using a disc-shaped ceramic membrane. The main breakthrough with this geometry of membrane is the drastic decrease in energy consumption for the same result. This is due to the fact that we abandon cross-flow filtration. We just move the membrane instead of moving a lot of liquids tangentially in front of the membrane to clean them continuously. So what we do is designing process, manufacturing the machines in the area of Montpellier, south of France, and incorporating modules and membranes. And so I will just now present 2-3 type of clients we can address with this heart of technology. This is an example of the client we have in the biogas production sector. In this example, the biogas producer is generating 62,000 tons per year of raw digestate. And our process is designed to crack this digestate into water and solid and liquid fertilizers. And it's a huge challenge because the increasing production of biogas is generating enormous amounts of digestate, and just land disposal of this digestate is becoming almost impossible. So now we have 7 plants of that sort in France, and of course we are interested in challenging digestate solution that are implemented in the Netherlands, where, as far as I understand, you need land for either sludge or digestate disposal. The second type of implementation we do is dedicated to again cracking industrial wastewater. Here it's about a food waste collection and transformation industry, and we concentrate all the wastewater of the site in order to recover the valuable material and send them to biogas production. And we match the water quality requested for both recycling on site for the cleaning needs and disposal into the matching the disposal limits. And finally, we also work on grey water, and for now 3 years we operate systems in big campings in the Mediterranean coastal area, and this is key to face drought by recycling, of course, as much as possible the water. At the moment, not all usages are allowed for recycled water, but the list of authorized usages is increasing. During this presentation, I mentioned the CapEx plus OpEx cost, and what you can see is that we are able to produce or to extract water at very low cost. For this example, the recycled water is produced at a lower cost than the network drinking water costs, and it's key to produce this water in an efficient way without subsidies. And these kind of systems are able to be implemented in sustainable blocks, sustainable buildings, either for potabilization of drinking water, of rainwater into drinking water, or of course production of clean water from grey water. I mentioned that there is a European standard which will help a lot implementation in all European countries. I give you the number, it's 16941 standard. And this new standard is describing how to implement water recycling system in buildings or sustainable or eco quarters. So we have been successful in many awards, and it's good for us to see that, especially during the Polytech fair, we succeeded in being recognized as a water extractor instead of a water treatment system. Thank you.
Thank you very much, Mr. Trouvé. I'd like to continue with the next French company presenting, and would like to give the floor to Dorian Journet. I will give you the control.
Thank you very much, Charo. Hello, everyone. My name is Dorian Journet. I'm the International Project Manager for Altirio. Can you hear me? Sorry, I can't see if I unmuted the mic.
Yes.
Yes, perfect. Thank you. So I will present you today HPO, which is a smart asset management solution that we develop, an AI-based solution. Just a few words on the company. We've been working for 31 years now on consulting in engineering and IT. We are based in France with about 180 employees in 12 branches, but we also have a few branches around the world, like in Morocco, Ivory Coast, and New Caledonia. We're mainly working in two fields in France and worldwide: the water and environmental engineering and the IT and GIS solutions, which we sell and which we try to expand worldwide. And also we do a bit of urbanism and support to public policies in France, but we don't do it worldwide. So we developed 2 years ago a technology that is called HPO that got already a few labels, including the French National Grand Prize for Engineering in 2019. And that technology that we developed is working on two main topics. The first one is to reduce the number of leaks in the future, and then to limit the duration of the leaks. So what we do is taking a lot of information from the clients, mainly the public, or most of them, the public companies, public entities that we work with, like municipalities. So we need two different sets of information. The first one is all the history of leaks that they have on the water network. So the past leak that they had, the most information that we have, the best it is. And the other one is the information on the network itself, the pipes. So we need to get the material, diameter, and lying depths, which are the most important informations. And then we can also add some more data into the AI to get renewal programs that I will talk about later. So basically, we take all that information together, we put it in the system, in the AI that we developed, and then with all that information, we come with a failure risk. With that failure risk, we do some renewal programs for municipalities. So just to give an example of how it works and what we can do, we worked 2 years ago in Nouméa, in the capital of New Caledonia, with the municipality. They had about 20 years of data on the failures that they had on the system, on the water network. And we took 10 years of this data to calibrate the model, and then we used the last 10 years of the data to validate the model. So basically, we understood that by taking all the information that they had of the system, putting it in the AI, we checked that if after 10 years of the first data, we had used HPO, we could have saved 50% of the leaks by changing only 5% of the network. So it was really an interesting result that we got with the municipalities. And that was the first one. So we tried the technology on Nouméa, and then many other cities. We've got 4 or 5 examples in France. We also worked in Namibia. I was based there for 2 years for the company. So we worked in different cities, and we're also working today with the research and development study with HPO with the Greater Paris. So we have now thousands of kilometers of pipes into the system, and we came with all the renewal program and the solution that we came. So basically what we do with all that information is for the municipality, the clients to get two things. The first one is a leak detection strategy. So we can say, according to the last years of data that you have from your system, we can say now that you should focus your leak detection strategies in these areas. So we don't look at I would say the DMAs and district metering areas, sectors, and all the leak detection, the usual leak detection strategy. It's more of a broader vision that you can have. And then obviously you need to do all the leak detection with the tools that you have. We don't do that part, but we can do it with the other partners. And then, which is the most important for us, is to do a replacement program. So today the municipality has to renew, let's say hopefully 2-3% of the network each year. But most of the time you don't really know how to do it, where to do it, what do you need to change first, how can you change it? So HPO is doing it for you. So we say you've got a budget, and then year by year we can focus the replacement program of your network to help you with the renewal. So we have a quite amazing return on investment, because if you save, for example, the example that we had in Nouméa is with 5% of the network change, we would have avoided 50% of the failures. So the return on investment is quite impressive. But what is also really interesting is that we focus on your data. We don't have one model that we use for all the clients, for all the municipalities and all the networks. every time we learn from your data to get a program with it. We have to adapt it every time. So the most data you have, obviously, the better, because we can calibrate and validate the model much more. Otherwise, if it's inefficient, I don't think it will be the case in the Netherlands. But otherwise, we can help the system with other examples to get to learn from the network. And we have a lot of results with it. And we do today, what we are looking for is not to directly to sell the technology to clients, to municipalities, to get some partners in the water sector that are interesting to get this technology with them, to expand the competitiveness on the markets, to get more products, more markets, more offers to win, so we can work together on the partnership. We're not looking just to sell once the technology to someone. We're just trying to find partners and then get to work with them on the technology with the clients that they already have. Okay. Thank you.
Thank you very much, Dorian. I will take it back.
Yes,
yeah.
please.
Thank you. So I would like to give the floor to a watchfrog, Gregory Lemkin, who will be pitching, by presenting himself, but not using a lot of sheets. So I'm very interested to hear his talk today. Welcome, Gregory. The floor is yours.
Thank you, Hero. Well, thank you for giving me the opportunity to give you a little bit of input on what's happening on the French situation, the French market, on our favorite topic, which is measuring the quality of water based on bioassays. I don't know if you can see, but behind me there's of course the logo of the company. I'm the CEO, Watchfrog, Laboratoire Watchfrog, which has been dedicated in measuring the effects of chemicals in on the endocrine system for now 15 years. We're actually pretty successful in this because we have methods that have been internationally validated by OECD, and actually our methods are now distributed in Netherlands. But I also wanted to take this opportunity to talk about the question of these chemicals, these micropollutants, these pharmaceutical residues, these endocrine disruptors in the water sector. I don't know, so if you can see behind me, there is also the logo of France Eau Biosurveillance, which is a federation we just created with the help of the French water team and the DREAM consortium. So the idea is that, and I've seen the presentation of Francis and you before, and the question of measuring the water quality and measuring the impact of these micropollutants is an ongoing question for now 10 years to 15 years in France, in Europe, and I know in Netherlands it's the same. And despite the amount of knowledge that has been developed, there's still issues to measure with the proper tools the impact of these chemicals. And without the proper tools to measure, then you cannot really solve the issue. That's why there is now a real concern by NGOs and authorities about the effects of these contaminants on coastal areas, on rivers, on the perspective of reusing water. So we have to define how to apply these bioassays. And we created this federation of companies and involving not only bioassays companies, but also big labs, big water treating companies, to try to push the work of the European Commission to implement these bioassays in the future regulation, and especially the Water Framework Directive. So I think my message this morning, as I had this opportunity to talk to you, was to try to see if on the Dutch side, if we could join our forces and work together to see how we can bolster these methods and define the applicability of these methods, and join our forces to push the work that is currently ongoing on redefining regulations at the European level to stimulate, to push for the use of these methods, and try to somehow redefine what we hear by water quality. So that's what I had to tell you this morning, and that's more a call for tender, more or less. So if some of you guys, or if you know people in Netherlands that would be interested in joining us for thinking together how we can push these ideas, and well, you're more than welcome.
Thank you very much, Lempien, Mr. Lempien. I know the discussion about the methodology for bioassays is a topic. I was just thinking about a talk I had indeed with some Dutch and German utilities on what do we base our discussions on, huh? Because that is indeed what set of regulations, what methodology do you use throughout Europe, so that we talk about the same methods, so you can also compare and make steps for treatment. The technology is there, but the challenge is partly on the monitoring. I agree with you. Thank you very much.
That's exactly right.
I would like to continue with introducing the Dutch companies. Would like to give the floor to Rudy Dijkstra from acquainted, also dealing a lot with preventive maintenance. So give you the floor, Rudy.
Thank you, Haro. Can you hear me clearly?
Perfect.
Okay, well, thanks a lot. First of all, I'd like to thank everybody for the opportunity to introduce acquainted and get acquainted. I heard a lot of quite a familiar stuff already with network monitoring and predictions and preventive maintenance and leak detection, etc. So I think quite some things could be let's have a look. Could be familiar to many of you. So I think this picture demonstrates a little bit the need for the water utilities. I think mainly in the world. I think the aging assets problem is one of the biggest issues that the water utilities are need to work on mainly. Although you do see that a lot of utilities are struggling with reducing leakages as well. But both are quite related to each other, and I think this picture demonstrates a so-called, more or less an autopilot for the water industry to be able to perform just-in-time actions and preventive measures. Basically, it tells you what to do, when, and how. I will elaborate on that. So basically, if we have a look at France or Europe mainly. France has a leakage rate of among 20%. In Europe, on average, it's 23%. So that's quite a lot of leakages that occur in Europe. On the right side, you can see the renewal program of a Dutch water utility, and one of their issues is that they are facing quite a so-called bulk replacement by 2050. And you have to imagine that nowadays it still is already hard to work on all the replacements that have to be done now. So by 2050, you can imagine that there will be a lack of skilled personnel to work on this replacement issues. So and with aging of pipelines, you also will obviously get an increased leakage rate. So both are quite significant. So the solution that we provide here is that we developed a technology that's able to inspect these water mains. So also for drinking water and wastewater. And we have three solutions in this case. One is the Aquarius. So it's a tool that is being propelled through the line with water pressure. It can collect data for many kilometers of pipes from 6 inches of diameter and upwards. So it collects data of almost 98% of all the failure mechanisms that occur in these kind of water mains. So it's quite a lot. And the most important thing here is that it is absolute data. So, and I think absolute data, if you want to be able to make predictions for these kind of water mains for the future, you need to have high reliable data. And data being absolute is quite a big advantage over here. So, one of the things that we developed here as well is that we can do it on a do-it-yourself basis. So in the Netherlands, we already equipped some utilities with these kind of tools, so they can collect data on the go. And I think the next tool also demonstrates the same thing. So we equipped Dutch mechanics from the utilities as well with this kind of tool to collect data on the go. In our opinion, every opportunity that there is to collect data should be used to make these kind of models for replacement even better. So it's quite an easy tool, this one. It can be used by almost everybody. You need less than an hour of training, and it's already being able to use. So the data is being collected in the field and directly uploaded to the cloud and being presented to the asset manager. So the asset manager directly knows the remaining life of the specific spot and also the probability of failure in time. So also for future failure rate. And the data is being used for data science purposes as well. So being the third solution that we offer, not included in this presentation, but you can visit our website. It's more demonstrated over there. So I think we heard a lot this morning already, and I would like to illustrate on this so-called bow tie analysis where we at. So basically, you do see in these kind of infrastructures two things. So one is on the preventive side, so the left side of the bow tie, and the other technologies are more or less on the right side of the bow tie. So working on leak reduction and the consequence of failure. And we aim to focus on the left side. So determine the degradation rate for each failure mechanism that occurs. So being able to also to develop a so-called maintenance regime for these kind of pipes, so you can treat them well before it fails. So if you want to have more details on how it works, so you can obviously contact me. So being a spin-off of WETSES and being nominated for the Deloitte Fast 50 Awards here in the Netherlands, we are willing to expand our business also to France. And France is for us a country that is quite high on the ranking list. So we're looking for strategic partnerships, and maybe today already found one. So Dorian, I'll suggest we have a phone call. And with that we will be able to work together on a future-proof water network, providing us with safe and healthy water for time. So thanks a lot. That's my presentation.
Thank you very much, Rudy. And yes, the link was there. I saw it as well. Would like to continue with the next speaker and like to give the floor to Koos Wessels of Cirtec.
PC. I have to ask, I think, for remote control. Click the mouse. Okay, yes, now it's working. Okay, thank you, Harry, for introducing me. I'm Koos Wessels with CERTEC. CERTEC is an acronym for Circular Technology, meaning that we are mainly involved in the recovery of resources from sewage, and we apply low-value residual energy for concentrate waste stream treatment. You see on my slide also the logo of PVS. Our partner for France is PVS. Miss Flora Babin is our regular contact there. So I'm going to present something about the recovery of cellulose. Let me see how I can, it works this way. It's not something that we thought of one day, okay, we're going to start recovering cellulose from sewage. Basically, the idea comes from a contest that was in the Dutch water authorities, where they statement was made that sewage contains more energy than it costs us to treat it. So theoretically, you can produce energy from sewage. With the goal set to reduce energy, our idea was to filter upfront everything out of sewage to lower the energy consumption for aeration, to reduce the sludge production, and with that the energy that is consumed by sludge dewatering equipment, and to reduce chemicals like polymer for dewatering. So in the first stage, what we did is we introduced a rotating belt fine screen, doing a test in 2008 already, and harvesting a material, what we refer to as cellulosic screenings. We did at a lot of treatment plants, we did long-term tests to see what is the impact on downstream processes, and I come to that a little bit later. But as you see in the picture, what you harvest from rotating belt fine screens is a material that contains high quantity of cellulose. And cellulose, it finds its origin in toilet paper, of course. Knowing that what you screen is a lot of cellulose, it also makes you aware that you have a product that might be sellable for higher applications. Well, the product coming from rotating belt fine screen still contains approximately 30% of contaminants, meaning that this is not a marketable product. So with that, we made an additional step, putting in line what we call a cellulose washer. So what we did is we put a piece of kit up front of the rotating belt fine screen to remove, I would say, hair, seeds, fats, and all kinds of contaminants that you don't want to have in your cellulose as a marketable product. Doing that, we came up with a material that has a purity of in between 96 to 98% pure cellulose. And we market that as a product called Resell. Then the wastewater or the sewage part of things, the treatment side of things is done within CERTEC, and the marketing of the cellulose, of the Resell, is something that we do from a company called Salvation, where we are in touch with the market, developing all kinds of products. Then what brings this to you? As I said, we did a lot of research over the last couple of years, long term, to see what the downstream impact is of our technology. But implementing this technology, you reduce basically the COD load to the treatment plant with 20 to 25%. With that, you see that the activity of your biomass increases, because a lot of these things that you remove remain in the aeration tank as inert material. And with that, we reduce the energy for aeration, say approximately 15%, the sludge production with about 20%, and of course the chemicals for dewatering. But what is maybe more important as well is that you have a product that you can treat as a high-end resource. We sell our material right now to the asphalt industry as an additive for that, and for production of biocomposites and construction materials. And we develop other markets like the bio-based chemicals. On the right side of the slide, you see a little bit our process, how it's working. But if you look at the impact what you have, an independent company, Competenzwasser Berlin, looked at it, what the life cycle analysis is and what the reduction of CO2 footprint is. And if you would apply the ReCell again as a product, you see that per ton of cellulose, we save approximately 2.5 tons of CO2 equivalents on a treatment plant. Then what could be the impact on for France? I looked a little bit into the sales of tissue paper in France, and that is approximately 690,000 tons of cellulose that is sold. It doesn't end up all at the sewage treatment plant, but based on some analysis and looking at the amount of sewage that is really treated by sewage treatment plants in France, a calculated value from what should end up in the treatment plant should be approximately 480,000 tons of recoverable cellulose a year from all the treatment plants. If you put the number of the 2.53 tons of CO2 equivalents to that, then if we would harvest everything, it would save approximately 1.2 million tons of CO2 equivalent. We can fly with about 150,000 people from Amsterdam to Sydney and back to do about the same, to have about the same pollutant factor. Why is cellulose so important? Cellulose is also a product that we import. Also in France, there's quite a degree of material that you import. So there is a market in France as well. And what we as a company do is we try to take away, because basically our customers are water utilities, so we take away the concerns of selling the product. So as a company, we also offer the sales of our material. This gives you a little bit an overview of all the research projects that we did. We did it on real large-scale plants. The STP Hydrolysis is a 390,000 people equivalent plant where we treated half of the plant with our technology and half without, to make a really good one-on-one comparison between the different treating lanes. And we looked for all kinds of applications of the product. Salvation was a project that we did for processing it in asphalt. We looked to make a polymer out of it for the CADOS system, what is cellulose-assisted dewatering of sludge. We made bioplastics out of it by in the form of PLA. And another interesting project might be the WOW project, where we want to do something additional with the residuals that we get from cellulose recovery. Because through a process of pyrolysis, we want to make a biochar of it that you can activate and use that again for the removal of pharmaceuticals and medicine residuals. On the right side, you see some products like flower pots that were made with our cellulose and bioplastics from sewage. A picnic table, what is a combination of cellulose and recycled plastic. And the asphalt, where our product is in the meantime a certified additive, is used widely in the Netherlands already. This was briefly what I wanted to tell you. So, well, feel free to ask. And
thank you very much, Koos. We will, and if there's any questions in the chat or the Q&A, we'll come back to them at the end, and then we'll perfect. Thank you for that presentation, Koos. Would like to continue with our next speaker. That is Christian Dino from NX Filtration. I will give you the controls, Christian, and the floor is.
Good morning to all of you. I hope that you hear me clear. I'm going to make a short presentation about NX filtration, and as the first slide title indicates, we are mainly concentrating on producing hollow fiber membranes. And these membranes are declined in three types of cutoffs, basically nanofiltration, ultrafiltration, and microfiltration. The company was developed as a spin-off of the University of Twente and is now employing about 40 people. And we are manufacturing hollow fiber membrane. And this presentation will concentrate on the so-called nanofiltration, for which we have developed a very specific technology. And this technology is in fact a very specific technology developed through research in university. It consists of a hollow fiber, and by applying a very specific technology in manufacturing, we apply what we call a nano filtration layer, which is of about 30 nanometer thickness. And by applying, in fact, a combination of polyanion and polycation, we are creating this nano layer. And this nano layer has a molecular weight cutoff of either 400 or 800 Dalton. If I'm coming back to the previous slide, in fact, we are reaching a very, very high rejection of, as usual with other types of membrane technology, removal of bacteria, virus, protein, micropollutant is the key area where we focus with this membrane technology, and also partial selective salt removal, mainly on the bivalent salts. Where do we see this nanofiltration to be applied? Basically, this slide is a little bit provocative, but basically we are looking to simplify the water treatment process by eliminating a lot of traditional pre-treatment of water, being coagulation, clarification, sand filtration, or even ultrafiltration, because our technology is capable to take heavily loaded water and to treat this water up to a level which is even better than ultrafiltration. And that is one of the key features of this technology, is that we are working on a cross-flow pattern in the membrane. And by this, we are keeping the membrane clean. But not only that, we are also able to control the property of selective separation, because the concept of nanofiltration is very close to what most people are used to, basically spiral wound, either nano or reverse osmosis. And we are working on three key parameters, which are the cross-flow speed, the recovery, and also the transmembrane pressure. And by utilizing these three key parameters, we are able to adjust the efficiency of our membrane and capable to treat everything in one single step. Most of the time, this technology will also be combined with other technology depending on the end purpose and the end goal of water quality which is required. So basically, it's a membrane technology which does not need any pre-treatment other than a fine screen in front of the membrane. The energy consumption of this membrane technology is about to a maximum of 0.3 kilowatt hours per cube of water treated. Total cost of ownership is usually for that membrane technology in the range of 0.2 to 0.3 euro per cube. And one of the key features is that we are not using any chemical material to facilitate the filtration process in front of our technology. which means that we only use chemical cleaning agents when we need to clean the membrane for normal fouling, such as biofouling and others. It's also very reliable technology because it can also be verified in terms of its property of removal by using integrity testing on stream when the plant is operating. And that also provides a quality assurance about the removal rate, whether it is on bacteria, virus, and also other micropollutant. The membrane material is basically a polyether sulfone modified to reach the nanofiltration capability, and thereby it's very easy chemically treated for cleaning purposes in a range of pH between 1 and 13, which means that this membrane is also simple to clean and simple to operate. I will simply come back to one example. This is one of the examples of a potable water production in the Philippines. That water resource was polluted basically with humic acids and also suspended solids. And we treated the water directly through the membrane. In this particular case, we have been using a membrane with a molecular weight cutoff of 800 Dalton. And it's a one-step solution to provide in a remote area potable water in one single step. And the color removal rate is above 95% with a recovery of 80%. So that is just one example, but we concentrate most of our efforts with this membrane technology on wastewater reuse, where we have a lot of examples and long-running demonstration plans, among others in the Netherlands, and also on high COD load, directly treating very heavy loaded waste stream. And we have one typical example, which is run by one of the large, well-known soft drink producer in Canada, where we are treating sugary waste with BOD load of about 10,000 ppm, and we bring it to 3,000, and the concentrate is then sold as a byproduct for the food industry for cattle. So there are plenty of examples, but as the amount of time is limited, we would like to simply say that we are looking for partners in France who could integrate this technology in complete water treatment process. And I will be very pleased to answer your question or to have separate discussions in the future. Thank you very much for your attention.
Thank you very much, Mr. Dinot, for your presentation. And I think, yeah, both from the French side and the Dutch side, we see this focus also on the micropollutants and the trace substances. So, and I think you're an interesting example of where you would be looking for OEMers in France for a typical cooperation. Huh?
Yeah, correct.
Could very well be possible. Yeah, thank you for that. This is a first webinar actually that Water Alliance is doing together with France Water Team. And even though today we don't have a B2Match matchmaking, this is something that we would also like to pose to you as a participant and a speaker, like what can we, France Water Team and Water Alliance, do in 2021 to, well, get more engagement between the technologies in the Netherlands and technology in France, and to actually, how can I say, to create that win-win that Mr. Bertrand was also referring to, that SMEs meet and join their innovations to provide added value for their customers in the end, and to have both part of the scope. So if you could put your ideas either to France Water Team or Water Alliance, what we can do in 2021, that would be greatly appreciated. Because we can take that up and well, do next webinars or matchmaking on themes. I think, Milan, I would like to also ask you to join me in this questions session. and also to maybe get a few questions from the chat or the Q&A. If you can put them forward, that would be great.
Yes, we have some questions. The first one is for Rudy from acquainted. Some people ask that you mentioned 20% of leak in the water networks, and does it concern only drinking water or sewage or the both of us?
Are you still with us, Rudy?
Yes, I'm still here. Yeah, I think in wastewater it is less than 20% because normally wastewater lines are not always pressurized. But you can imagine that these type of systems are consisting out of the same type of material, so they deteriorate more or less on the same basis. The only difference normally is the age. So in the Netherlands, the age of the water drinking water system is among 50 to 100 years old, and wastewater, at least pressurized, is there since the 1970s. But in the way they deteriorate, yeah, there's a difference. But yeah, there's no paper or no research available at this time who illustrates the amount of leakage. But I expect it will be less than 20%. But hopefully that answers the question.
Perfect. So we have another question. It's mostly a remark for Cirtec. During the presentation, you explained how you kept the cellulose, but there is also the problem of wipes, the baby wipes that are in the wastewater. It's a very big problem, and how do you manage this kind of waste?
Well, baby wipes, yes, I think they are a problem everywhere. So also in the Netherlands, but normally you would try to get rid of them. If you look from a sewage treatment point of view, you like to get rid of them already in the core screening. So preferably we don't want to have it in our system as well, but there is not a problem if it would pass the core screening and come into our system, because we will remove these baby wipes in the first filtration stage, so in what we call the cellulose washer, and get rid of it. Is it a big problem for our technology? No, because we have a hard filter, and applying our technology, you also secure that it don't end up in your treatment plant. But yes, I think it is a problem. Yes, we don't want people to flush these kind of things, but the message seems to be difficult to get it across. Does it answer your question?
I think so.
Very good.
We have also a question. I don't know exactly who is addressed by the question, but an interesting question. And there is an opportunity. Is there an opportunity for resolving the wastewater treatment for the smaller town, maximum 10,000 people?
I briefly touched on a company called Bluecon today, who has a full physical chemical treatment line, especially for those kinds of sizes. Containerized units, and also interesting models. In general, if you want me to introduce you there, please send me an email. I think in general, Milan, if somebody wants to touch base with one of the speakers, please reach out to us and we can connect you, of course. But I think, yeah, especially this full physical chemical treatment is very well suited for the smaller scale municipal treatment plants for towns. Yeah. Do you know any of your members who is involved in that field as well, Milan? Or?
Yes, we have some that propose some solution regarding some specific kind of treatment.
Emmanuel Trouvé from Nereus. We start with a small wastewater system producing recyclable water at 100 p. So we can manage very low, very small communities, or also incorporate them into eco quarter or buildings. So and we can manage both full treatment plus including production of recycled water, or just extracting recycled water. Both solutions are possible.
I remember some
100 p.
Mr. Trouvé, I recall that you do some grey water treatment as well with irrigation reuse possibilities. Yeah.
And also we can manage all the wastewater, not only the grey, black and
True. Yeah, understand.
And this at an of course at an affordable price. 100 p is not our technical limit. We could do it for a smaller quantity, a smaller p, but it is affordable from 100 p, so comparable to other systems.
So, Mr. Trouvé, now you are online, so to speak, and you have your microphone off. Could you give us a short, your idea on how we could, in your opinion, find this or increase also in next year, to do an event, for example, to be able to have Dutch and France companies connect? Could you give your preference for such a, would you say, like, of course we would prefer a physical meeting, but it seems that it will still be 2021, it will still be quite a bit of digital, at least in the beginning, but maybe you have an idea as well. Could you share that with us?
In France, we have an ongoing what we call a decret, a prime minister decision, together with the environmental minister and the health minister, that will allow experimentation or full-scale installation of water recycling system for 5 years in a demonstration. This is a long enough demonstration period, and it will be open to any opportunities to demonstrate new systems, new device, new solutions, new process. And I think we could have let's say small consortium of Dutch and French SME responding to some of these projects, and it will be a first step to introduce integrated solutions. For example, we in EUS we could consider integrating NX filtration membranes in our solution, and to respond to propose some project in France under this new opportunity, which is it's not already signed because it's under public consultation at the moment, but it will be signed in the coming weeks.
Okay. I think also possible European projects also might offer that opportunity for cooperation, but thank you for your suggestion. Any more questions from the chat, Milan?
Yes, there was a question regarding the collaboration between France and Netherlands. So Emmanuel began to ask, because the question was, are the French utilities open to collaborate with foreign company, and do we need strategic partnership? Regarding the French partners, do you want to add something like that regarding the collaboration with the foreign companies? And do you have an idea regarding the position of the utilities in France that could be open to collaborate?
I think that the demo project from Mr. Trouvé was already an interesting,
was one of the
concrete option in that sense. Yeah, well, maybe I would also ask the participants to maybe share the ideas with us, Milan. I think Koos raised his hand. Would you like to make a brief statement, Koos, or have a question for the group?
Well, I do have a question indeed. Yeah, I saw in the chat also something about the difference between France and the Netherlands in terms of sewage works. It says 17,000 plants and 350 in the Netherlands. This is correct, but this 17,000, I won't say that it will be a kind of distribution, small, bigger ones. But my question would also be. How far is there a technology comparison between what we do right now in the Netherlands and in France? Is anybody familiar with that? What are the drivers for France to look for innovation, for example? Is there also, I would say, energy reduction the biggest driver, or are you looking for CO2 footprint, or are you looking for resource recovery? What is driving the French market to innovation?
I think we saw a few examples, Coles, in the presentation from Mr. Bertrand, but it could be an interesting topic actually for a webinar, couldn't it be, for next year? I don't know if somebody can briefly answer, Coles, because we also have to move slowly to an end to keep a little bit the time. Is there a French company or who could briefly reply to Coles? No, I can understand it. It's quite a generic question. We will share the presentation.
I could add something to that topic, if
please, please, Mr. Gregory.
Yeah, just to mention that one important, well, here I am. One important driver for this. I mean, I'm not going to speak about saving energy or CO2 footprint, because obviously I'm not an expert in that, but there's an ongoing need to solve, as I mentioned, the question of impacts of the chemicals in water and in water resources, in rivers and coastal areas. And this is a driver that could be of great importance for water treating technologies, because right now the water sewage plants in France are meant to treat organic matter, but are all systematically considered not efficient to treat chemical pollution, which we know that is not absolutely true, because obviously biological activities, bacterial activities are treating part of the chemical contamination. However, we saw in Switzerland how the implementation on new regulation on micropollutants drove the market very rapidly on treating water systems. So this is why the question of implementing bioassays to measure this contamination, this pollution, is also a driver for pushing the authorities to improve and have better water treating systems to get rid of this impact.
Thank you for that suggestion. I do imagine, Mr. Lemkin, that part of it seems logical to me that part of the industry would also wait for possibly EU regulations, more stricter EU regulations in that field, right? To have a directive.
Yeah, and actually, surprisingly, believe it or not, but the industry is not necessarily against these new methods, because right now in France, I don't know exactly the situation in Netherlands, but right now in France, the application of the Water Framework Directive led to a systematic analytical campaigns, which were very frustrating for industrial, having the impression of looking for substances at very low levels, having a lot of impact on their tax, and not necessarily being relevant for showing the efforts that they were making to improve their waste. So bringing new tools is also bringing realistic tools and reliable tools to show the efforts that industrials are making. So yeah, that's
we should have a position in finding solutions to tackle it. Not wait for directives to be there, but be part of a practical solution. Is that what you're also saying?
Yeah, they're looking to be. There are actually a lot of industrials are already members of our France Eau Biosurveillance, especially pharmaceutical companies, because these guys are making huge efforts to better treat their waste. Yeah. And right now, the regulatory tools for measuring these efforts are not there. Clear. So in different levels, as I said, for industrial waste, but also for improving reuse, for improving level of water quality in the environment. These bioacids are, I think, required to drive the market, and
it could be an interesting topic, maybe to well, to keep in mind. Yeah, no, thank you very much, Milan. I think keeping a little bit the time that we promised for our participants. I don't know if any final remarks from your side. I do see that the sun is shining in France.
Yes.
Same for the Netherlands, but it looks good, the sun. It puts a smile on my face, that's for sure.
Okay, so maybe for the other question we have, we can address it after the webinar, for example.
Shall we do it like that? Then, because I appreciate very much for France Water team to do this together with us today. I hope in future we can meet again in person, but until then, from my side, I can only say stay healthy, and I wish you good water business. And thank you very much, Milan, for you and your team for doing this.
And thank you for all the organization.
Okay, and I wish everybody a good day, and au revoir.
Bye bye all.